everyone, in this video we're going to go through the solutions to the trial exam, so exam number 1. So in this exam it's only 60 minutes, so you really need to make use of your 15 minutes reading time and thinking about which questions you can confidently answer and just making sure you take your time to answer them correctly. You don't want to be rushing and trying to get the whole exam done. Because for some of you there will be questions that you will just find extremely difficult, and you don't want to be spending time on trying to get marks there when you should be focusing on getting what you can do correct. Alright, I've already done the solutions, so I'm going to be just talking to these solutions. It kind of makes the video a little bit shorter as well. Alright, your first question, and usually your first two questions, are usually either a derivative or an antiderivative question. They're pretty straightforward. It always turns up every year. So for this question here, we're just using the chain rule. So make sure you're familiar with the chain rule, the product rule, and the quotient rule, and when to use them. So the only way you can get familiar with which one to use is to keep doing questions. Alright, so here we've got the chain rule and just applying the chain rule. This format here is fine. You don't need to expand it. Obviously you wouldn't expand to the power of 4. You can put that 5 into the first bracket, but it's also okay to leave it out the front. Alright, question B is a quotient rule. So the quotient rule, chain rule, and product rule are all on your formula sheet. This is worth 2 marks. So 1 mark given to applying the quotient rule correctly. So you can see that's here. So there's your 1 mark. And we do have to substitute in pi on 3. Now when you are substituting in, just make sure you take your time, and if there are negatives involved, you just don't get them mixed up. Alright, so using as many brackets as you can to make sure you minimize the chance of making an error due to a negative. Alright, so what have I got here? So yeah, a bit of simplifying required. Obviously you need to know your exact values, so we've got sine pi on 3 and cos pi on 3, and you can't go in assuming, oh, I don't need to know my exact values. You need to know your exact values. Hopefully you have realized by now a lot of past exam questions are based on, do have trig and do require you to know your exact values. Alright, question number 2. So this was quite a hard one, and I haven't actually seen a question like this before. The thing that makes it hard is we don't have the same base. Alright, we've got a 2 and base of 3. Now, if we could get them to the same base, that would make it so much easier. So let's say if we had 2 to the power of x plus 3 equals 8 to the power of x plus 2, we can change that 8 to be a base of 2, which would make it so much easier. But this requires you, I guess, to just do a little bit of thinking about your index laws. So 2 to the power of x plus 3, we can actually separate that to become 2 to the power of x times 2 to the power of 3, and 2 to the power of 3 is 8. So that's what I've done on the left hand side. On the right hand side, just separating the base of 3 as well, and then we get the 9. So basically we've now got our 2 integers, so we don't have the x's attached to that, so I've just divided both sides by 8 to get 9 over 8, and then divided both sides by 3x to get the 2x over 3x. Now using your index laws again, this is the same as 2 over 3 to the power of x, and then you can take your log. Now we're not really used to seeing log of base 2 on 3. And you can see the format of the question requires you to use the change of base rule, which we have covered, but it is not on your formula sheet, so it's probably a good idea to really understand the change of base rule. So you can change the base to whatever you like. So for this question we needed to change it to the base of e. So you can see there we've got log base e over log base e. Alright, so you can change that to whatever base you like. And then you can see we've got a fraction as our answer, so here. So on the top of your fraction in your argument, we've got 9 over 8 goes on top. So think about in this expression, 9/8 is on the top and 2/3 is on the bottom, so that goes on the bottom. So to get your 2 marks, all right, obviously, sorry, 3 marks it was, probably, I would say that would probably be 1 mark, maybe 2 for that. No, maybe not 2 for that, sorry. 2 for here, and then 3 using your change of base. All right, so quite a tricky question, but remember, even if you get 1 out of 3 or 2 out of 3, that's better than 0 out of 3. All right, moving on to question number 3. So we've got an antidiff. So we're having to find the antiderivative, so we do need to put plus c. If it says an antiderivative, you don't need to put plus c on, but perhaps just put plus c on, it doesn't make it incorrect. The only time you don't need the plus c is when you're doing a definite integral, because you substitute the values in. So this formula is on your formula sheet. I think no, just trying to think. I don't think it is on your formula sheet. So the coefficient of x just comes out the front as 1/3. So just remembering that formula. If you do have a number other than 1 up the top, you can put that in front of your integral. All right, part B. So here we've got a little bit of information. We have to find g of x. So we've been given, we know that when x is equal to 1/4, g of x is equal to 5. So that's what we've done on this side. And then the derivative is equal to that. So basically, if we find the antiderivative of the derivative, we get g of x. All right, so that's what I've done on the other side. Don't know why I did it the other way around, but anyway. Why did I do it? Oh, okay. Yeah, so I had to find the antiderivative first, and then we got the plus c, and then to find the value of c. That's why we did it that way. All right, so 2 mark questions. So obviously you couldn't do anything with x equals 1/4 g of x equals 5 until you found the antiderivative. So probably 1 mark for the antiderivative and 2 marks for substituting it back in and getting your final answer. All right, question 4. So here we've got a general solution. So again, needing to know your exact values. So for this one, we're solving for all real values. Okay, so it means that we have infinite solutions, so we need the general solution. So solving for 2x, so 2x equals pi on 6, so getting that from your exact values, and then just substituting that into your general solution, which is here. Now, if you ever forget your general solution, just think about, well, this is positive, so cos is positive in the first and the fourth quadrant. So basically we're going 2 pi n. All right, so if I put in 0, we've got 0 there, plus or minus pi on 6. So pi on 6 in that quadrant, pi on 6 on that quadrant. Because I was solving for 2x and I need to solve for x, just dividing everything by 2. So the 2n pi becomes n pi after dividing it by 2, and pi on 6 becomes pi on 12. Now you need to write n as an element of z, because otherwise n, what is n? All right, you need to state what it is. So you do need to have that for full 3 marks. So for this one here, you'd probably get 1 mark. Would you get a mark for that? Probably, yeah. Sorry, I'm just looking at what I scribbled out. 1 mark for, can I get rid of, oops, didn't want to get rid of all of that. Oh, sorry guys. All right, so I'll just tell you what you get 1 mark for. So solving for 2x, and then probably 2 marks for your general solution, and then 3 for everything correct. Yeah, because I would say a few students might make a slight error in the general solution, so just allowing for that error as well. So 3 marks is quite generous for that question, I feel. But anyway, moving along. All right, so here we've got a sketching question. So we've got to sketch this hyperbola. So we've got 1 over x plus 2 minus 1. So we've got to label asymptotes with their equations. All right, it's not just a matter of putting your dotted line on and leaving it like that. Often we see with their equations, and axes intercepts with their coordinates. So you need to put the actual coordinates on. So you can see I've got the equations there and the coordinates here. On the side, I've just calculated the x-intercept and the y-intercept. There was nothing previous to probably guide us with the shape of it, so just make sure when you're sketching that they're not hairy. I think you know what hairy graphs look like now. They're a smooth line and they don't kick up. Like, what I mean by kicking up is kicking up like that. All right, your curve approaches the asymptote. All right, doesn't kick back up. All right, you'd hate to lose a mark just because you were sloppy with your sketching. All right, find the rule and domain. So here we've got to find the rule and the domain. All right, so if you're someone who's prone to forgetting things in a question, just highlight it and then afterwards go, okay, have I done the rule and have I done the domain? All right, inverses, I feel like you're quite good at them. So just switching your x and y and then solving for y. Just make sure your final answer you leave as f negative 1 equals x. All right, because that's the function, the notation we need to use. All right, so you'd hate to lose a mark just because you didn't write that. All right, and I'm serious when I'm saying that. So you need to put that notation in, and then we've got our domain. All right, question 6. So looking at some probability here. So you could use the z-score formula for question A. I just love drawing the normal distribution, so I just did that. So we've got x is less than 49. So 4.9 is 2 standard deviations below the mean, which is 5.3. We want z is greater than a. So using using symmetry, these areas are the same, so that means a is equal to 2. So that sort of question should be an easy mark for you. Given that the probability of z is greater than 1 equals k, find that. Okay, so we've got a conditional probability formula question. So let's first of all look at where k is. So here's k. So k is when z is greater than 1. All right, so 1 standard deviation. So using symmetry, this area is the same over here, which I already shaded in blue. Now 5.1 is the same as 1 standard deviation below. And then 5.3 is our mean. So basically what I've got here, all right, is the whole area. Let me just use a different color. All right, so this whole area minus what I shaded there in pink, and then I'm left with just that red part. All right, so we want, given that it's less than 5.3 is the blue, and then give then less than greater than 5.1. Oh yeah, sorry, greater than 5.1. So 0.5 minus k. 0.5 coming from the fact that 5.3 is, let me just draw it again. All right, when your mean is in the middle, all right, so here's 50%, 50. And as a decimal, it's 0.5. So that's where the 0.5 has come from. And then that red section is 0.5 minus k. All right, so subtracting this part here. All right, so greater than, given that, it is that. So greater than 5.1 is the red section. And so the pink section was just k. So a lot of highlighting. All right, so simplifying this now, you shouldn't leave it as a decimal in a fraction. So you can rewrite it as 1/2 minus k over 1/2. Now dividing something by a half is the same as multiplying it by its reciprocal, so 2 on 1. All right, so that's what I've got here. And then I just expanded it. I would say they would also accept that as an answer, but probably not leaving your decimals in a fraction. It's just, yeah, not simpler, its simplest form. All right, moving on to question 7. The point P lies on the straight line y equals a half x plus 3. The length of the line segment OP from the origin O to P is a minimum from the origin O to P. Find the coordinates of P. So I just did a rough sketch over here, and you can see I've drawn the line of y. The line is going from the origin, so from here is 0, 0, and it's perpendicular to the line. Now, I'm pretty sure there was a question like this on your first SAC, maybe your second SAC, I can't remember. All right, so when it's perpendicular, it means it's going to, so they're perpendicular, so our gradients, so you can see the gradient of the line there is a half. So the gradient of your perpendicular line is the negative reciprocal. So we just flip that fraction. So instead of being 1 over 2, it becomes 2 over 1 and multiply it by a negative. So my gradient is negative 2. And it goes through the origin, so we don't need to put plus c, it's just plus 0. Then we want to know the coordinates of P. So P is the intersection of these two lines. So I've just let one equation equal the other and solve for x. So you can see I get x equals negative 6 on 5. And then to get the y coordinate, we substitute that in to get 12 on 5. So it does ask for the coordinates, so please write them as a set of coordinates. Don't just leave it as x equals and y equals. All right, so a 3-mark question, maybe 1 mark for finding that gradient, 2 marks for finding x, and 3 marks for finding or getting the final answer. All right, question number 8. So we've got this function here, an exponential function. Show that the x-intercept of the graph is 1 over k log base e of 3. So remember, in any show that question, we just pretend that the answer is not there. You need to basically read that as find the x-intercept. All right, so to find the x-intercept, we just let y equal 0, and then we just go on to solve it. All right, so make sure you're also showing sufficient working out along the way. Don't just maybe go from here to here. All right, you need to show where that log has come from. All right, average value, so fairly new to you guys, but the average value formula is not on your formula sheet, but it's not hard to remember. So let me just write it down here. So 1 over b minus a b f of x dx. All right, so it's just basically the same as a definite integral. The only difference is we have this fraction out the front. So 1 over b minus a. All right, so here's our, let me just change the color I'm highlighting. All right, so there's a, there's b, whoops, there's b, sorry. So then you can see I've done that out the front. I haven't put the minus 0 because it's just 0 anyway. Then finding the antiderivative. So you can see I did that on the side. That's why I've pointed to that. Was that a hard one to do? Oh no, I found the antiderivative, sorry. Just substituting it in. I think I did it on the side just because, actually I don't know why. Why did I do it on this? Oh, I did the definite integral on the side, and then I multiplied by the 1 over 1k log base e on 3, just because it was going to be too messy otherwise. All right, so was a bit tricky because it's logs, but don't be scared of logs. Just make sure you know your log laws. I'm just trying to think if there's anything here that I need to make you aware of? No, I don't think so. Okay. All right, and then we've got average rate of change. So in a previous exam, they did have them next to each other. So average value and average rate of change are not the same thing. So I think examiners were getting sick of students getting them mixed up. So they put them both on an exam, and here you can see they're both here again. So they are not the same thing. So average value, there's your average value formula here. And then average rate of change. So you can see the average value on an exam one. All right, so you need to remember that formula, but it's just a definite integral, and then you just got that fraction in front. All right, average rate of change is just doing your rise over run. So if we're going between x equals 0 and x equals 1, you can see I've just substituted that into the rise over run formula. So x2 minus x1, and here we've got y2 minus y1. So we want to know when it is negative. So here it has to be less than 0. So just solving for k. Just also knowing that whatever your base is doesn't have to be e. If your argument is 1, then it's 0. All right, so when your argument is 1, so in that bracket, when it's 1, whatever your base is, log base 10 of 1 is 0. Because basically with your logs, it's saying e to the power of what equals 1. And using your knowledge of index laws, e to the power of 0. All right, so that's why it is 0. All right, I think we're nearly to the end. The function h has a maximal domain and rule given by blah, blah, blah. State the domain and range of h. So you can see just on the side here, inside your argument, that cannot be, sorry, it has to be greater than 0. It can't be 0 and it can't be negative. So you can see I've just done x plus 2 is greater than 0. So x has to be greater than negative 2. It cannot equal 0. All right, because it's basically saying e to the power of what equals 0. That just does not exist. So, I don't know why my eraser doesn't work. That's so annoying. There we go. Thank you. All right, so that's your domain and your range. So this is why it's good to be familiar with a log graph, because you need to know, its endpoints. So even though for this one, we're starting at negative 2, you can take on any y values. Excuse the bell in the background. All right, explain why the graph of h does not have a stationary point. So basically the gradient is always increasing and is never 0. So just always saying it's increasing is fine. So your graph, I think we actually draw it. Next one we do. Yeah, it looks like that. So it's always increasing. It doesn't have a gradient will never equal 0. Did I write that? Yeah, gradient. Oops. All right, sketch the graph. All right, so we need to label any asymptote with its equation and intercepts with their coordinates. So here we've got the one asymptote at x equals negative 2. All right, make sure it doesn't cross your asymptote. And these intercepts, it's a bit hard to actually figure out where they are. You should note that E is approximately 2.4, I think, or something like that. It's 2 point something. So if we're taking away 2, it's going to be just past 0. So you can see here. And then that means for your curve that we're going just below for our y-intercept. So log base e of 2 minus 1. So this was worth 3 marks. So always 1 mark for your asymptote. So just write your asymptotes, make sure they're a dotted line and you can clearly see them, and you've written your equation. Don't get your x and y mixed up either. For the shape, so you do want it to look like a log graph and kind of go how it should. And then you got your x-intercepts and your y-intercepts, and writing them as coordinates too. Oh, still going. I thought that was the last question. This must be the last question. Maybe not. Let me just check. Yes. Okay. Question 10. A random variable x has a probability density function f given by blah, blah, blah. All right. Show that k equals 3 on 14. So we just ignore that answer. We do not put it in and then use it in our solution. So you can see I've just left k all the way through. So it with probability, if you've got a probability density function, basically it is equal to 1. All right, so that's how we solve for k, and we did quite a few of these when we did continuous probability. So then you're just solving for k. So k equals 3 on 14. Just looking here though, just a little hot tip, all right, because you might see this. When you've got a power that is a fraction but not a unit fraction, so you know that 4 to the power of a half is the same as the square root of 4, which is 2. So when you've got 4 to the power of 3 on 2, that is the same as saying 4 to the power of a half cubed. All right, because understanding your index laws, you multiply those powers. So that's going to become 2 cubed, which is 8. All right, and then 1 to the power of anything is just still 1. All right, so just making sure you know that index law. All right, and then finishing with an easy question. All right, so finding the expected value. So all we need to do is multiply that function by x. Putting in your value of k, it gave you the value of k, so you can just substitute that in, which is good because then you're not missing out on marks if you couldn't do the previous question. What makes this difficult? Oh, here we've got another power. Let's just do this to the side. So 4 to the power of 5 on 2. We can separate that to 4 to the power of a half to the power of 5. So it becomes 2 to the power of 5, which is 32. Yeah, so 32 minus 1 is where the 31 comes from, and then just multiplying 6 by 31 and then simplifying it. So just make sure you put it in its simplest form, especially this being the very last question. There would be an expectation that you do put it in the simplest form. Don't put it as a mixed number. You can leave it as an improper fraction. I'm just trying to think what else to say. Yeah, no decimals, but you probably wouldn't do that anyway. When simplifying, you should simplify all your questions. Also doing surds, so if you had the square root of 20, which I think was one of these questions, all right, you do need to simplify that. All right, so the perfect square that goes into 20 is 4. So that becomes 2 root 5. So just simplifying that. That was one of the questions, I'm pretty sure. Where are you? Was it here? Nope. No. Oh, look at that. Line's following me all the way up. Don't know. I thought it was on this one. Anyway, good work, girls. Bye.